Hi, David Vizard here, and you are watching PowerTec Tech. Just as a reminder, this is the No BS channel. It's also something that we don't rely on advertisers for revenue. We get that from YouTube. So we can say what we want about products so you get the real facts. In this edition, you're going to find that you're going to get some turbo information you will find on no other channel. I doubt that anything like this has been published before. Now, I'm using my ECOBOOST 2.3 Mustang for low buck drag racing as well as practice for road racing. Here I'm showing PowerTec 10 friend Robert Weatherly doing his thing on an auto test. This is where we'll start because it doesn't need a lot of fancy safety equipment because you rarely get over about 60 or 70 miles an hour. I've spoken about during the video about time to do this, time to do that, etc. I've kind of logged my total hours on this, and I would say between the intake and the exhaust I've spent 10 to 12 hours. Now, was it worth it? Well, it looks like it is, because it's worth about 30 horsepower and about 30 foot-pounds of torque for no cost. And here's the deal. If you use a 3-inch down tube after you've done this, you will find that you'll get about 20% more horsepower increase than you would have done with the stock turbo housing. Now, let's get down to some tech stuff here. First off, the biggest evil to power output from a turbo engine is exhaust back pressure. And here's the problem. Those internal wastegate turbos are not flow efficient. They are very convenient, and it's an ingenious device to be able to put a turbo onto a car that still makes very effective horsepower without the huge cost of a separate exhaust turbo and wastegate and controller, etc. In other words, it makes a very convenient package. Now, does it work? Well, hell yes. The big bugaboo here is pressure ratio across the engine. A typical internally wastegated engine has about a 2-to-1 ratio. That is 2 pounds of exhaust back pressure for every pound of boost it generates. That is the bad side of the coin. That's the moldy side, right? Yeah, sure, that turbo still works. That's because turbos are great at pumping air. But basically, you are cutting off its maximum capability to produce horsepower. Let me tell you why. When you get boost up to a level where it's more than the back pressure needed to generate it, what happens is you get a very defined, well-defined power stroke on the inlet stroke. Let's say you're using 35 pounds a square inch. Well, on the inlet stroke, instead of sucking the charge in, some of the power that's been used to develop the boost is returned because now you've got 35 psi pushing that piston down. So it's a power recovery system there. With boost pressure being lower than back pressure, the back pressure is a energy absorbing feature which only makes up for the power loss by the virtue of the fact that the charge pushed into the cylinder has twice as much oxygen and fuel. So the boost there. The other thing is, if you have this negative pressure ratio across the engine, i.e. more back pressure than boost or less boost than back pressure, what will happen is it will tend to dilute the charge in the overlap period, thus reducing power once more. Also, now this is a kind of swings and roundabout deal. Sometimes having the back pressure up can reduce the chances of detonation because it dilutes the intake charge. But by the same token, it heats it up. So it kind of sometimes goes one way and the other way. Sometimes it will reduce detonation depending on the chamber shape and the burn rate and things like this. And sometimes it will increase detonation. Now I've had experience where it increased detonation, and getting that back pressure down to less than the intake boost pressure greatly increased the anti-detonation capability of the charge by virtue of a much cooler charge at the time of spark. Let's look at this. How much horsepower do I think we can gain from this? Well, hasn't been tested yet. However, I have done some very crude flow figures. They are very crude, and I'm not going to show them because they are not truly representative of what this exhaust housing may do. What I've got to do here is build a flow fixture which flows the entire turbo, and we measure the RPM and the air passed by that turbo under a given set of conditions. That I am going to build. It's going to take a while because I've got so much other stuff, but I see that this is well worth it. I am pretty sure that with a careful enough work, I can get 100 horsepower from this intake / exhaust turbo setup on a stock internal wastegated turbo system. Now, one more thing I must mention here is we also did the intake housing. So I'll show you what we're doing there as well. Now I'm going to start our turbo mods with the exhaust because that is the most influential part, and we get the best bang for the buck overall in this case because the back pressure is so high. So let's have at it. How to modify the housing on your internal wastegate turbo exhaust. Now, unlike our usual moves in showing modifications, I'm going to diverge from normal. What I am going to do here is show you the finished housing and then indicate where I remove metal and why. So here is our finished housing. Now you'll know what the original shape is and what it looks like when you take yours off. You'll realize that butterfly, that's the valve, wastegate valve, is a big rectangular block in the way of the exhaust stream. That's just one thing. So here we go. Let's take a look at the finished turbo housing. Now here, let me just illuminate that, is where we get a nasty flow transition. This here is a sharp edge. You'll notice that this annular ring here goes into the scroll. The exhaust comes in here and exits there, running straight into the exhaust turbine. Now it has to make a turn just here, and all it's got is this very raggedy sharp edge. So what I'm going to do here is polish this area here and hopefully get that sharp edge off. So here we go. I've used a fine disc like this, a 240 grit, and just rounded these edges off here. Right, minimal amount, maybe 20 thousandths off the edge at the most. So the area of this hasn't got much bigger, but it should be much more flow efficient coming round this corner here. Right, we'll see how that works out. This is what you could call blueprinting the turbo. This is what I would have done on engines where they had to go together and they were stock, so I would just tidy up everything that was there and cut it the way it was meant to be done from the original factory design. I can't pour a mold of this turbo housing. You're going to have to follow the arrows here. What we have is a situation where this valve here, the wastegate itself, is really restrictive to the flow. Now this here, the housing comes to the exhaust pipe at an angle of about 60 degrees. Not good for flow around this corner. In fact, it'll be almost non-existent past a certain amount of flow. So what we do is, to get around this, what we do is we radius this here, generous radius here, so that gases coming out will flow around, and they'll come out and they'll go across like this. So all of this here, let me just swing this around. So all of this area here needs to be relieved. This radius here, all up here, and this surface here, so that it gives it more room across here, because it will be disruptive. Now look at how much that gets in the way of flow when that's open. That's fully open there. You'll also notice that this edge and this edge here have been ground off, so they present less cross-sectional area to the flow. Very how shall I say, finicky to do. Also the bosses here have been rounded off, and this corner here. From this you should be able to see that a lot of time has been spent reworking the form of this here. Now, as for time, this cast iron that this is made of should have been would have been battleship armor in World War II. It is very hard, but a good carbide cutter, olive half-inch carbide cutter, will cut it nicely, and it will complete the job without blunting the tool, assuming it was sharp to start with. I advise it to be sharp. Now let's just turn this over and look down the other way. As I pointed out earlier, the exhaust gases come down here, around here, and exit into the turbine blade. Now I've mentioned this earlier on. This edge here is, as it comes from the factory, is a very ragged edge. It's a micro ragged edge, and the angles it presents for turning into here are the worst possible angles you can imagine. Just cleaning it up like this here, and I've probably taken only about 15 thousandths off and cleaned it up like this, is probably worth 10 or 15 horsepower all on its own. From here in, we've got the contour that matches the turbine. There's a step here, so I've tried to angle that step off at about 45 degrees. Let's look further down the bore of this exhaust housing. Here's a few other places you need to remove metal. First, on the right hand side of the view we see here, there is a hump just where I've arrowed it, and that needs to be blended smoothly into the area where the wastegate valve is. Now let's take a look at the bottom of this view here. This is an area which needs deepening because it's got to approach an area where it's choked down. And if you deepen this area here, you will see how you can enlarge the area coming up to the wastegate valve to give it more space to flow past the wastegate valve. And everything else on that is about pretty much obvious, so we should be good to go as far as this part of the port's concerned. Here's the entry side of the exhaust turbo housing. What I've done here is enlarge it over the stock size quite a bit. Not because that's going to make any difference to the flow on a stock head, but I am prepping my ECOBOOST head. And to get the exhaust up to scratch, it was necessary to port junction face, as you see here. Here's where I'm at on the turbo housing to cylinder head interface. You'll notice I've enlarged the ports pretty substantially here. So in so doing, it's gone through here into the water jacket, here into the water jacket, and here. So what we're looking at is having to do some welding here. I'm going to break into this one deliberately so that we can weld it up. Now what I'm doing is I'm matching my turbo housing to this, but I suggest what you do is you match your turbo housing to the marks on the gasket if it's a used one. That will give you a good guide as to what it should be. Now watch these arrows. What they're indicating is the grey gasket material. I got a sheet of it from Mr. Gasket, so it's easy to get hold of. Just look it up in the Summit catalog and you'll find it. And I sandwiched it between the exhaust manifold, turbo manifold gasket and the cylinder head, the gasket that I'm indicating now, the metal one, and the head. Tightened it down. Now that gasket is a very accurate fit on those studs, so it's not going to move. This allowed me to match the ports on the head to the ports on the turbo housing, because I cut the gasket and the ports at the same time. So that allowed me to match them very closely. Now with your cylinder head, unless you're going to how shall I say, do the porting job on it to get the port size I'm using, then you will cut the port to the smaller size that's as per the exhaust manifold on the head. Now, my advice here is if you take that head off for any reason and you're not going to port it, then just match your manifold gasket, that's the grey one, to the size of the port in the head, but just enlarge it slightly to smooth it out. Then you can match it precisely to the one in the turbo. Here's the gasket that I cut to the shape of the exhaust port after I've ported it. Now I'm not sure I've gone all the way yet. This is just a cleanup cut on the turbo itself. As you can see, it's pretty marginal in some places. It doesn't match up, so I may have to make the ports bigger, but you'll get the idea. Here I've marked around there and there, and these bolt hole rises here and here, lumps, bumps, whatever you want to call them, they can be taken out so that that's a continuous curve there. That's pretty thick back there, so it's not likely, you shouldn't go through it. If you have, you've cut out too much, obviously. Well, that brings us to the conclusion of our exhaust turbo housing modifications. In part 2 of this edition, we're going to deal with the intake turbo housing. Now, being aluminum, that's much easier to do. Also, there is not much work that you can do on it anyway, but there is one crucial modification that can be done that is not much more than a 5-minute job. Anyway, that we'll deal with in the next issue. We'll also deal with how much horsepower it's made. Greg Gordon of Greg's Airplanes and Automobiles is going to dyno test it on his 2.3 turbo Mustang. Now, like I said, experience indicates that we should pick up about 30 horsepower, but it does depend on the engine you've got to start with. Obviously, if you do this on a smaller turbo, it'll be proportionately less, and on a bigger turbo, proportionately more. But that's my figure for a 2.3 EcoBoost. That's my best guess at the moment. So, if you liked this video and found it interesting and found it to be probably unique in its subject matter, then please subscribe. We need those subscriptions, all of this R&D we're doing. Thank you for watching, and I will see you on the next episode.